So for this question, I'm only going to do the maclaurin expansion, so part C. In part A, you found f prime prime. Here I started by writing, this is from the formula booklet. Now, we're being asked for the x squared term, which is then the third term in the series right there, but for h of x, and h of x is a composite function. So it's the product of two functions. So instead of this, we're looking for h of x, which is equal to h of 0 plus x h prime of 0, let me clean that up, plus x squared over 2 h prime prime of 0. All right, so we're going to find, and conveniently, we already have the second derivative of f. So let's find the first derivative of h of x, which will equal 2, well, I don't really care, because we're just going to find it. Derivative of the first times the second, plus the first times the derivative of the second, and h prime prime. Okay, I'm lying, I don't want to do this whole thing. So what's the first g of, and we're looking for this at 0. What's h prime of, well, no. Let's just figure it out. Very well. H prime prime of x is equal, so it's the derivative of the first times the second plus the first times the derivative of the second. That's the product rule for this first piece right here. And I'm going to do the same thing right here. Plus derivative of the first times the second plus the first times the derivative of the second. All right. And now we want to find this at 0 because that's how maclaurin's function. And we already have f prime prime right there. That's our second derivative. So if I just replace this, put a 0 right here, that'll be 3/4 of 1 to whatever power. So that's just 3/4. So that's nice. I'm going to start with that. So this will be 3/4 times g of 0. This is g right here. And cosine of 0 is, cosine of 0 is 1. Okay, so that'll be 3/4 times 1. Plus f prime of 0. Well, I guess I should probably find this. So let's put this over here. F prime x is equal to, okay, I'm actually going to figure this out. F of x is equal to 1 minus x minus 1/2. Therefore, f prime x is equal to minus 1/2 1 minus x minus 3/2 times minus 1 equals 1/2 times 1 minus x minus 3/2. All right. And f prime of 0 will equal 1/2. Because again, this will just be 1 at the bottom. So this will be 1/2. And g prime of x, so g prime of x is going to equal minus sine mx. You got to be careful this, right? The chain rule always applies, times the derivative of the inside function. So g prime of 0 is going to equal minus sine of 0 times m, and the sine of 0 is 0. So that's 0 right there. All right, so that'll eliminate itself. Plus f prime of, well, it's going to be the same exact thing. Interesting. Okay. Now plus f of x times g, f of 0, and f of 0 is 1. We have it right here. All right, 1 minus g prime of, oh, it's g prime prime. So my notation's not very pretty there. It should have been a little cleaner. Perhaps a lot cleaner. It's a little bit late. And the second derivative, well, let's figure it out here. So the second derivative is equal to minus cosine mx m times m. Does that make sense? Right, because m is not a variable. So it's m this becomes minus cosine, keep the baby, this is multiplied times this, all right, equals minus cosine mx times m squared. Very well. And now g prime prime of 0 is equal to minus cosine of 0 squared, which is equal to minus 1 times m squared, which is minus m squared. So this is 1 times minus m squared. So all of this to say, the h prime prime of 0, this is worth, okay, this is worth 9 points. So you have plenty of time to actually do this smoothly. Is 3 over 4, the zeros cancel out, minus m squared. Now, this is, this is h prime prime of 0. And now going back to this piece right here, this is for f, this is the third term in h. And the coefficient of this, which means that the coefficient of the term in x squared is h prime prime of 0 over 2. And that's equal to minus 3 over 4. And it's also equal to 3 over 4. Nope. Okay, that's equal to minus 3 over 4. So therefore, h prime prime of 0 is equal to minus 6 over 4, not over 8. It's equal to minus 3 over 2. And we found that h prime prime of 0 was this bit right here. So 3 over 4 minus m squared equals minus 3 over 2. What are we trying to show? Find the possible values of m, okay? So that m squared is therefore equal to 3 over 4 minus 3 over 2. 3/4 minus 6/4. Uh-oh. I have a bit of an issue there, don't I? Fortunately, it's a plus. That helps. There we go. Right. We add 3/2 to both sides, and we add m squared to both sides. Very well. So it's 3/4 plus 6/4, which is 9 over 4. Therefore, m is equal to plus or minus 3 over 2. And I think we're done. I think this one, so the induction problem isn't necessary for this, to see how this kind of flows. This part is kind of useful. And then I think just kind of seeing that this will apply to f and being careful, like this little bit right here. You know, there's a bunch of work that needs to be done with the first derivatives and the second derivatives. And I almost got caught by my notation not being clean for this one. Very well. I think this is entirely within your capacities.